All right, welcome. Thanks for joining section 2.7, our last section of the chapter. Very exciting. So we end on like a sort of cool note, graphing rational functions. So in 2.6, all we talked about was like vertical asymptotes, zeros, domain restrictions, horizontal asymptotes. Now what we're going to do is mix all that together so that we can graph rational functions. But we're going to do this by hand. So if you're like sitting there with your calculator by hand or next to your hand, put it away. You don't need it. You're not going to be allowed to use it, and we're going to have to do this without it. So going into this idea, we're just going to sort of talk about these like 6 steps that we're going to follow. First is exactly what I said in section 2.6. We're going to simplify. Let me change the thickness of this. We're going to simplify if possible. So if it's not possible to simplify, totally fine. We'll leave it exactly as is. Next, we find and plot the y-intercept. So find and plot the y-intercept by evaluating f of 0. So we substitute 0 into the function. What that's giving us is the y-intercept. And we're going to plot that on our graph. Next, we find the zeros and plot as x-intercepts. Next, we find the asymptotes. So that's horizontal and vertical asymptotes. And graph as dashed lines. Dashed or dotted, either one of those. Next, we use critical points as intervals for sign tests. So use critical points, and we'll talk about what that means. As intervals for sign test. And then last, sketch using a smooth curve. So looking at this list, 1, 2, 3, and 4, that was all stuff from section 2.6. 5, once you see it, it's not tough. And then 6 is just, draw the actual graph going through all this stuff. So we are going to do some examples here because there's not really much to cover if we just talk about notes. So sketch a graph of f of x equal to 2 over x plus 5. So first things first, this is already simplified. I'm going to draw some graph over here for where I can be sketching all of this. So the first thing that I said, and it really the order that we do these doesn't matter, but let's find the y-intercept first, f of 0. If I substitute 0 into this function, I get 2/5. So I know 0, comma, 2/5, right about here, is the y-intercept. Next, the vertical asymptote. The vertical asymptote is when I look at that denominator and when it's equal to 0. So I would get x equals -5. So I'll go to -5 on our x-axis. Okay, that line is just gonna, there we go. Oh, okay. And we draw this dashed line. This dashed line is not part of the function. And we'll label it x equals -5. That dashed line is the actual asymptote. It's the line that is sort of like a boundary that I can't cross over. Horizontal asymptote is y equals 0. So that's my x-axis. I draw my dashed line going across there, and I'll label it y equals 0. Again, horizontal asymptote was because the degree of the denominator was larger. The y-intercept we already covered, so then zeros. The zeros is when I look at the numerator and say, when is that equal to 0? In this case, that would be nowhere, so there are none. So then we've done steps 1, 2, 3, and 4. What we want to be talking about now is step 5, using critical points to figure out sort of the sign. So if I'm looking at this, what I need to know is like here at -4, is this function positive or is it negative? Because I don't know if the rational function will look like this or like this. So what I do is I substitute in, here we have x and f of x. I substitute in -4. If I go to this function and put -4 in, I would have 2 over 1, which is 2. So -4, comma 2 is a point on this graph. All I really cared about was whether or not it was above this line, y = 0. This right here tells me, okay, so my rational function must be up here. Actually, I didn't even notice our y-intercept right here. I could have already said I know this function's up here because of that y-intercept. What I also need to know then is, hey, what's going on at -6? Because I don't know if I'm up here or down here. If I substitute -6 into this function, I would get 2 over -1, which is -2. So I know -6, -2 is a point on this graph. And my function needs to be bounded by both of these asymptotes. So there I just graphed our rational function by hand. All right, we're going to skip ahead a little bit. We'll do these other examples in the examples video. And what I want to get to is the idea of a slant asymptote. So slant asymptotes, what slant asymptotes are is that case where the numerator has a degree that's higher than the denominator. There's no horizontal asymptote, and instead there's a slant asymptote. A slant asymptote can be found by taking the quotient, so essentially the division, from the division, so the quotient from the division of polynomials. And sort of an interesting note about that, that's regardless of remainder. So when we're talking about a slant asymptote, the remainder we don't really care about. So I'm going to do one example here of seeing that slant asymptote as well. First thing, as always, that I like to start with is what this, or giving me a little axis to be working with. There we go. And we'll do this one in blue just for funsies. First thing I'm supposed to do is simplify this. So this is x plus 2, x minus 2 over x minus 1. Nothing cancels there. So I'm going to start with the y-intercept. I take f of 0. So if I substitute 0 into this, I get -4 over -1, which is 4. So 0, 4 is a point on this graph. Next, my vertical asymptote. Vertical asymptote, I look at the denominator and see when it would be equal to 0, which is at 1. Go to x = 1, and I draw that dashed line. Next, my horizontal asymptote. I look at the degrees. When the degree on top is larger, there is not a horizontal asymptote, and instead, there will be a slant asymptote. We'll get to how we do that slant asymptote. Let's go to the zeros. Zeros is when I look at the numerator. So I have x = -2 and x = +2. So at -2 I have a 0. At +2 I have a 0. The slant asymptote can be found from the division of x squared minus 4 divided by x minus 1. Because I'm dividing by x minus 1, I can do synthetic division by 1, since this is like a linear thing. So I'll have 1, 0, -4. 1 times 1 is 1, add 1. 1 times 1 is 1, add, I get -3. Remember that we do not care about the remainder. So what this says is x plus 1. So y equals x plus 1 is my slant asymptote. If I could not do synthetic division here, I would have to do long division. That's why we sort of covered it earlier on in the chapter. But please do recognize when you can do synthetic division because it's shorter. Now I need to graph the line y equals x plus 1. If I'm graphing that my y-intercept is 1, I go up 1 over 1 or down 1 left 1. This is still an asymptote. It's just not horizontal or vertical. So I draw it as the dashed line. So I've done my y-intercept, done my vertical and horizontal or slant asymptote, done my zeros. Step 5 would be to use sort of sign analysis or substitute in some values to figure out where the function is. But I know because of this x-intercept, the function must be right here. I can't also have a function up here because if I did, that would fail the vertical line test. And on the left of this vertical asymptote, I have these 2 points, which means the function must be up here. And again, I can't have anything down here or else it would be failing the vertical line test. I can't cross through this because the nature of an asymptote is that I can't cross through it. All right, that gives you a little bit of an intro to sketching. You do have, I think, 3 more just quick sort of slides that give a little bit more practice, hopefully relatively short. So I would recommend going and watching those just to get a little bit more of an example.